Then I will call CST planning, sir. Then we can start. We start, sir, because now 70 participants are there, sir, and already one parallel presentation is going for reset also, sir. So that's why, sir, today strength is 70 only, sir. Can we start, sir?
Yes, please. Yes, please.
Yes, sir. Sir. So good morning, sir, and good morning, friends. So today presentation will be given by Deputy CST Project Tele Unit, and it will be presented by Mr. Kashyap, DST TCAS. And sir, as advised in last meeting, sir has instructed to keep OEM also in our meeting, sir. So today, OEM's representative from MEDA, HBL, and Connex also has joined. Ashish from MEDA and Muralidhar from HBL, and Tarun and Jiten from Connex, sir. They have joined. And welcome to all of you. And sir, we would like to announce the award for best questions in the last week webinar. And K. Samil Prasad, SSC Signal Guntur, and Ramesh Kamulu, AST Nellore. Congratulations to both of you. So, sir, now we will directly go to presentation. Kashyap, are you ready?
Yes, sir. I'm ready, sir. Shall we start?
Please go on, Kashyap.
I hope I'm audible. Am I audible to everyone?
Yes, Kashyap, you are audible, Kashyap.
Okay, let me share my screen. Good morning, everyone. Today we are presenting the implementation of TCAS in auto section. As not everyone is aware of TCAS, it is a relatively new implementation in South Central Railway also. I would like to give a brief introduction about what all we take into account how TCAS itself is implemented. The first thing, let us talk about what signaling has. Signaling is basically IOs, inputs and outputs, and how we are going to process it with some kind of logic so that unsafe movements are not permitted. The IOs are basic. We are all from SNT and we know it. But signal aspects and point positions, track occupancy. Track occupancy, we have either track circuits or axle counters, LC gate status, whether it is closed or open, and block instruments. With all these things, we check the concepts of what backlog route is, setting of points in those, setting of points in overlap, isolation, how we release it, and what the berthing portion is. That berthing portion is nothing but where the train is intended to stop. Now, train operations. There are three people who are involved in running the train. The first one is signaler. Signaler is the station master. You can also call who maintains the signals is also a signaler, but signaler who is actually signaling the train, taking off the signal, and traffic controller. Traffic controller is the one who decides what kind of traffic to be pumped into the section, what train to stop, what train to move, these things. Next, the loco pilot and guard who actually run the train. Now, how do we automate these things? Automation has been done for each of these people. Signaler, how do we help him? Signaler, we have given interlocking so that the signaler who is actually taking off the signals is able to not create, he is able to ensure that he's not going to create any unsafe situation. This is how interlocking is acting. The same thing, there are certain automations that can be done. The first thing is, for signaler, we are giving automatic train control. Traffic controller also, we are giving automatic train control. Loco pilot and guard, they have two types of systems: automatic train protection and automatic train operation. See, the automatic train control is traffic automation. The decisions now taken by the section controller can be automated, and the section and the things, route setting, taking of signal, that also can be automated when certain conditions are met. So you take off a signal, set a route when certain conditions are met. This also can be automated. This is automatic train control. Automatic train protection is what interlocking is to the station master. That is to loco pilot as what interlocking is to the station master. So it tries to prevent SPAD, it tries to prevent collisions due to human error. When loco pilot may ignore, or there might arise a situation where he's unable to view a signal, or certain situations where he's unable to take action, this automatic train protection system itself takes action and it breaks the train, it stops the trains. This is automatic train protection. Compared with this, automatic train operation is a much advanced, is a much more advanced version of automatic train protection, and a combination of this achieve driverless functionalities. These ones we are seeing in metro, where the train itself actually runs without driver. It can run without the driver. Driver only takes care of the closing of doors. What ATP systems are actually present in India? Hello?
Kashyap, you are audible. Now we can see your presentation.
Okay, I was unable to share it. Okay. The signaling basics, IOs, and what concepts are there, signaling aspects, all these things are there. These are the inputs and outputs that we have. And next are the concepts: backlog, route, berthing portion where the train intends to stop, overlap, and isolation. These are the basic concepts of interlocking. In train operations, there are three men who are involved: signaler who actually takes off the signal for the train. Next, traffic controller who is deciding what kind of traffic is to go, what train is to stop, how many trains to go, these things. Loco pilot and guard who actually are involved in the running of the train. We automated with three kinds of systems: automatic train control, automatic train protection, automatic train operation. Automatic train control is achieving automatic taking off of a signal, route clearance, route setting, and taking decisions regarding the traffic control. What kind of traffic is to be coming? These decisions are taken by automatic train control. Next is automatic train protection. Automatic train protection is like interlocking for the loco pilot. So it tries to stop the train whenever unsafe situations may arise, like prevention of SPAD, head-on collision, rear-end collision, these things. Automatic train operation is achieving driverless functionalities. So what were the ATP systems that were earlier tried in India, and what are the ones that are running now in India? The very first thing is auxiliary warning system. It was tried out in Mumbai Suburban, both of Western Railway and Central Railway. The first picture that we can see over here, that is the auxiliary warning system. It actually had train magnets which detected the signal aspect, and magnets were placed on the track and under the loco, so that loco can detect the signal aspect, and thereby it can either it can warn the loco pilot of the signal aspect of the whether when he has to reduce the speed of the train, and if he fails to acknowledge that, the system will take care of it will automatically break it. Next is anti-collision device. Now we wanted to prevent collisions of trains, because there were accidents like Gaisal where hundreds of people died due to train collisions. That was due to manual error when there was non-interlocking. Now, anti-collision device, it is based on GPS. GPS, from GPS we take the direction, we take the location of the train, of each train running in the section, and then we also detect the direction of the train, and depending upon direction and location we are able to detect the collision. But the disadvantage in this, major disadvantage, was the accuracy of GPS. So when there was the accuracy of GPS is around 10 meters. So adjacent lines also, sometimes there could have been chances of redundant braking, where train used to detect the collision scenario when there were trains were on adjacent lines. So this was the disadvantage, and then we went for TPWS. It is basically a European system where we are detecting the location of the train from copper loops placed on the track. We detect the speed, we detect the location. So now we are aware of these things, and we are also, these copper loops, they also pass on the aspect of the signal to the train. With these, we are able to detect unsafe scenarios. We are able to prevent SPAD. These things are there in train protection and warning system. This was implemented in certain sections of Southern Railway and NCR. But European system, it is costly, and copper things are generally prone to theft. So we have gone for, and not only that, we have also gone for indigenization, and this has brought train collision avoidance system. It is from around 2013 that we have started to implement that in South Central Railway. And let us see more about train collision avoidance system. So train collision avoidance system is the initial name that has been renamed as Kavach now. So this has three major things. One is the onboard system. Onboard, whenever we say onboard, it is all about loco. Next is stationary things, stationary TCAS or stationary Kavach, and trackside Kavach. So whatever station we need aspects of the signal. So these are taken from the actual signaling interlocking systems. We take the aspect of the signal from ECR relay, and we take the occupancy of berthing tracks, calling on tracks, and some there are some other tracks that we take, that is basically called train length measurement, that we'll talk about later. These are the basic signaling inputs that we taken from for Kavach. These inputs are repeated relays are picked up, and that is wired to stationary TCAS. And next, detecting absolute location. Absolute location we detect from an RFID tag. We are all aware of how RFID tags work, where we are used and widely used. That is a very good technology. It is a cheap technology. You can embed some data onto a magnetic strip, and you place that, you give some waterproofing type of protection to that, and you have an RFID tag. So this RFID tag, it has the information of absolute location, and you go place that at that particular location where you are intending to do that. So we place all these RFID tags on the track, nearly placed in the block section at around 1000 meters distant from each other. So when the train passes over it, the train, it has an underslung RFID tag reader. So it detects the position of the loco, and that position of the loco is transmitted through UHF, ultra high frequency radio wave, to the stationary TCAS. So stationary TCAS, it detects what signal is ahead of that train at that particular location, and it passes on what is the signal aspect to the train, that is also through the radio wave. This is more detail about what the data flow is. The data flow is nothing but what I have already said, except I did not mention about speed detection. Speed detection is done through a pulse generator, speedometer. Let us call it the speedometer. Now, this, we have detected the absolute location. We know the signal aspect. Then how do we tell how far the train can run? How far the train can be run is a numerical number. It is, we give it in terms of number of meters the train can run. That is called movement authority. Based on the location, signal aspect, and not only the signal aspect that is ahead, we also need what is the signal aspect that is ahead of the signal. This is signal number 1 that we are looking directly at, and towards what signal it is running, the signal number 2, that is in advance of this signal. We take these two aspects into consideration, and then we give the movement authority, how far it can be run. So all these things are done through radio only. All these are passed on to the train and passed on to stationary TCAS through radio. And now whenever there is, say, a danger signal, and the loco pilot, now when he generally sees a danger signal, he applies brakes. Say he has failed to apply the brake. With the the movement authority would only come till the foot of that signal, which is in danger. So when the movement authority is only up to there, the TCAS, it automatically tries to brake the train. It automatically tries to apply the brake, and it stops the train just before the foot of the signal, at a certain distance before the foot of the signal. So we have other features like prevention of head-on and rear-end collision. We also detect the direction of the train with the running of train. So when two trains are running on the same track and they are heading towards each other, then that is a head-on collision. Both trains are automatically braked. And rear-end collisions, when both trains are running in the same direction, or say one train is stationary and other train is approaching it, then that is a rear-end collision scenario that is also detected. And because we are also passing on the aspect of the signal to the train, this is displayed on the interface that is given on a screen that is given to the loco pilot in the loco cab. So we also have an indirect advantage. Say when there is fog and poor visibility, we can pass on the signal aspect directly in the loco. And we have another feature saying wherever speed restrictions are there, that also can be passed on to the loco, and speed can be regulated accordingly. So the basic concept is RFID layout. We initially in the design phase, we prepare something called an RFID tag and tin layout. We have talked about RFID tags. So each of these things is a tag, is an RFID tag. So we have signal foot tags, normal tags, turnout tags, and all kinds of tags. Turnout tags are generally placed on points, and each section of the track, it is divided into something called tin. Tin means a track identification number. So whenever we are clearing, say, this signal 1, and we also detect, now we need to know where the train is headed to. So how do we detect where the train is headed to? We take the point position. So we know, say this 14 point is normal, 15 point is normal. Now we know that this is headed onto this signal. So that is why we take point indications. We wire point indications so that we can know the direction of the train in the station yards. So now in this case, we say for clearing of this signal, what all conditions we need, and when this signal is taken off, how much can that train move. This is defined in something called a table of control. So let me show you this table of control. I'll show you for one particular movement S1, say it is headed on to S4. So it is moving on to the common loop. We know that the entry signal is S1, and with these point positions, we know that it is headed on to S4. So it is we know what is the entry signal aspect. It needs to be yellow with route indicator. Position 1 is the presence of route indicator. And the aspect of exit signal. Exit signal is nothing but the starter. So when that is there, we already survey these inter signal distances, point distances, everything is surveyed, and all these numerical numbers are their absolute locations. So we know the absolute location of say S1 signal, and we know the absolute location of S4 signal. So the inter distance, when S1 is yellow and with route, HG with route, and S4 is RG, we know that the train can run up to S4. So this is how much movement authority can be given, and that is how much it can move. This movement authority is passed on to the loco TCAS through radio. So this is how it works. Now we also detect berthing track clearance. Berthing track is CL1, this one. So we also wire berthing tracks, and we detect that this signal whether this track is occupied or not through TPR. And next comes track identification numbers. So whenever these N62, 63 and 65, as I told you, all these are already divided into track identification numbers. Each portion of a track is divided into tin. Okay, the boundary of tin is divided by the RFID tags. So whenever I need to give movement authority based on the S1 signal aspect, I also detect this track clearance, and whether any train has occupied these tins. Okay, so these are how it runs, and we also have loop line speed control feature. I know it is already passing with a point in reverse, so I need to restrict the speed to 30 kmph. So I define how much speed is to be given. So this is how it is done. This is the basic feature of how TCAS actually controls the train. And how do we decide what what parts of stationary coverage are to be installed where? How do we decide it? So whenever signaling inputs are wired, what signaling inputs, what equipment actually take in the signaling inputs are three types. One is STCAS, station TCAS, that is for station. It has input cards, and whatever signaling relays are there, they are wired to these input cards. And next is LC TCAS. It is nothing but station TCAS, but with lesser number of input cards. And next is RIU. It is like a slave input gatherer to the station TCAS. It is analogous to object controller of EI. So now how do we decide? Now the basic thing is we install tower at every station, and as a rule of thumb we are going for 40-meter towers. RDSO has said, advised everyone in its specification that zonal railway has to install 40-meter tower. So we install 40-meter towers at all the stations, and now based upon this, we know when 40-meter tower is installed, how much radio coverage is there that we get. We have software simulator tools. This is called RSSI, radio signal strength indicator. So based upon that, we know how much RF coverage is available and where. So when we have a say midsection gate or traffic gate or any end cabin where RF coverage is available, so we install a RIU, remote interface unit. We install that, and whenever RF coverage is not there, it is simple. We install a tower, and each tower is connected with LCD cars. So this is how we make the decision making regarding what equipment to install where. Next, what are the types of surveys that we carry out for studying the feasibility? Whenever it is just common. These are common things. Whenever we go commission things, we see space in relay room, what are the spare contacts that are available, how much power supply is available, whether it is really sufficient to install our equipment or not. If it is not available, then you go augment it, use a new IPS, use a new battery bank, do something like these things. And then we also have NMS. NMS here is network monitoring system. A network monitoring system, we install that in the test room. Generally in the signal control or telecom control room, we install that for each division. And in that division, we can monitor the status of TCAS, stationary TCAS and loco TCAS also. This and network connectivity is through E1. So we check the possibility of whether how much network connectivity, how much it is feasible, what cables to lay, all these things are there. And now SOD infringements. SOD infringements for any self-supported structure, it should be any self-supported structure should be at least 2.36 meters away from the track, central line of the track. We see that this tower location where we are proposing, we are not going to infringe the track. And we are going to see the RSSI, as I already said, radio signal strength indication. That is, we cannot go about first installing towers physically and then checking whether we have signal coverage or not. That is just too costly. So what we do is we use a simulator tool. There are certain tools in desktop. One such software is LegoWave software. We give the position GPS coordinates of where our tower is going to be installed, proposed to be installed. We define all sorts of parameters, antenna gain, antenna height, all these things. And we see a particular GPS coordinate where the receiver is going to be there, whether it really can have the RF coverage required strength or not. This is how we take the decision regarding where we have to install our tower, how many number of towers, what is the height of the tower that we are going to be installing. Not only that, whenever we are going for installation of any station TCAS, what we need to really look at is sanction for closure of RUBs and ROBs. Once we have installed our station TCAS, we should not be wasting more amount of money for installing station TCAS or TCAS at LC gates that are already being sanctioned for closure. This is one aspect of sanctioning, and another aspect is how many times we are going to redo our TCAS work. Each LC gate that is going to be defined in TCAS table of control, when that is removed, there needs to be an alteration in the station TCAS logic. So how many times are we going to do the work? So we see how far it is possible to really eliminate the gates when it has already been sanctioned for closure. In automatic block section, the major considerations are what to install and where to install. So let us see, there are 3-4 schemes of auto section, how auto section is really implemented from a signaling point of view. So auto section, what is the communication requirement? This is an auto section that we are talking, station A and station B, and these are the signals, each spaced at 1 kilometer. Now the station TCAS of A, it needs to cater to the block section also, the automatic block section also, and station B, it has to take over. Now let us call this as handing over station, and let us call this station B as taking over station. Now let us say what our proposal is that the station communication coverage of station A, this is the communication coverage of station A, this is the communication coverage of station B. Both these things are having overlap. This is what we propose. Now let us say why we need this. Why we need this? All our signals, auto signals, are placed 1 kilometer apart. Okay. Now let us say we don't have a or the communication overlap of station A and station B. Now our train is running. Let us call this signal 1, let us call this signal 2, 3, 4 and 5. Now let us say we are at signal 1 and we don't have a communication overlap between all these things, and my communication of station A is going to end at signal number 3, and station B communication is going to end at station number at signal number 3. We don't have a communication overlap. Now our EBD of emergency braking distance of train is 1200 meter, and let us say the switching over time of communication from station A to station B is 10 seconds. Let us say it is 10 seconds. When the train is traveling at 120 kmph, it is going to travel for certain distance between in this time, in this 10 seconds of switchover. I know the signal information of station number 3, and whenever I say of signal number 3, and whenever I say that I need to brake the train, to apply brakes, okay, before applying brake I am going to cross signal number 4 minimum, and say I don't have the information of signal number 4 in station A and it has not yet switched over to station number B. Station TCAS, loco TCAS, it has not switched over to the station number B, station B. Now what is going to happen is my loco is going to be blind about the signal aspect, and there may arise uncertain situations and unsafe situations. So this is why we have certain communication overlap between station A and station B. How much? It is 2 kilometers or 3 kilometers based upon the design speed. How much is the braking distance is going to depend upon the section speed, the design speed, and how much communication, how much distance the train would have traveled before the communication has been taken over by the next receiving station. This also depends upon the section design speed. So based upon these considerations, it is going to be 2 kilometers to 3 kilometers. At 120 and 130 it is 2 kilometers. At 160 and 200 it is going to be 3 kilometers. So our speed is 120 only. So we, in our implementation, we have taken the overlap to be 2 kilometers. Now let us talk about another scenario where station A and station B are really wide apart. They are wide apart. Now the rule of thumb is station A and station B, when they are having towers of 40-meter height, they can generally cover 4.5 kilometers from their location. RF coverage is 4.5 kilometers from the location. So now if these two are they are going to need some communication overlap. Let us say that is 2 kilometers. So 4.5 and 4.5, 9 kilometers minus 2, it is going to be 7 kilometers. If these stations are more than 7 kilometers apart, we cannot have a communication overlap. So what do we do in that case? We install another tower and consider that to be another station, and we do the communication overlap again. This is necessary so that there is no abrupt braking or there are no unsafe situations. In this communication overlap, I need the signaling data to be passed to both the stations. So there I'll need more number of RIUs. RIUs are input gatherers, and in this section, I gather in auto section, I gather the signaling inputs through RIUs. Signal 1 is only wired to station A. So we have one RIU over here, and 2, 3, 4 need to be wired to both station A and station B. So there we need RIU related to station A and station B also. For example, let us talk about these things. Now my basic idea the basic idea of station TCAS is make the communication before breaking it. So this is Falaknuma onto your left and Budwel is onto your right. So when we are traveling from Falaknuma to Budwel, we first define the communication entry limit of Budwel, make the communication with Budwel and only then break the communication with Falaknuma. So all these signals, this is the LSS of Falaknuma. It is wired only to Falaknuma station TCAS. 1653 is wired only to station TCAS of A, Falaknuma. This 1743, 1861, 1953. These three signals are wired to both Budwel and Falaknuma. So these need to have more RIUs. They need RIUs of both Falaknuma and Budwel. This is the typical RIU connectivity scheme. Station A and station B. If we see this, TX and RX, they have been brought onto one fiber. All RIU connectivity is through dark fiber of OFC. Okay. Transmit and receive have been brought onto one fiber. Let us talk about this RIU1. So RIU1 is having a primary path. It is connected to station TCAS through this one, through one fiber. It is connected to station 2, auto hut 2, to RIU2 through another fiber. The same fiber in the section, same fiber number in the section. This is the primary path. How do I have the protection path? It is through another fiber, this one. So this is making a ring. So we have a neat ring over here. RDSO states that we need to have a double ring for channel A and channel B. This is another ring. Two channels, channel A and channel B of RIU. RDSO states that we need double ring protection. This is a typical RIU scheme. Now what kinds of auto sections do we have? We have auto sections where there are the first case. Let us talk about the first case, where we have continuous auto signals, continuous track circuiting. There are no auto gumtis, no auto gumtis. Sanat Nagar to Lingampalli, it is that way. There are no auto gumtis, no IPS, and no, because there are no auto gumtis, the case of having signals in signal ECRs and TPRs of the track circuiting in the auto gumtis. So it is continuous track circuiting, and in auto section we give the aspect of the signal. In signaling interlocking itself, we have something called running circuits. So slots run from signal to signal, and all this wiring and logic has been done in the location boxes itself. So these things are called running circuits. So here, in such case, what do we do? TCAS scheme, what do we do? The one option is to have RIU placed at each location box of the signal. So this is one option. Another option is we gather two or three signals. We repeat, we introduce another location box at the center, have signaling cable and centralize all the ECRs and TPRs in that location box. And in that location box, near to that location box, you place an RIU and wire all the repeated relays in that RIU. So which of these two you choose is depending upon the cost. Cost of your signaling cable, cost of trenching, cost of RIU, cost of what cable that we are laying, 24 core, 30 core, 12 core, what kind of cable we are laying. So this, based upon cost considerations, we decide what scheme to use. And next kind of auto section is where auto hut is available, where the IPS is available, but signaling inputs are not available in the auto gumti. Here also we have two options. So first, the hard method, RIUs at each signal. Another is centralizing all your signaling inputs through signaling cable in your auto Gumti. You centralize, and the auto Gumti itself, we install the RIUs. The advantage in installing RIU in Gumti, in auto Gumti, is it is very simple. Electronics always mean prone to lightning. More electronics means more failures. So the number of RIUs when you install at each signal would be simply more than installing RIU at a centralized location. This is one consideration. Another consideration is installing RIU in auto hut means installing RIU hut in a more secure location. So the maintainability increases, the accessibility increases, and we are not placing the electronics in location boxes which are prone to heat. So it is supposed to reduce the number of failures. And next is RVNL scheme, or a new kind of auto section scheme with MSDAX. MSDAX. With MSDAC, we have removed continuous track circuiting, and we have MSDAC throughout the section for detection of track occupancies, and there is slotting between signals, and all these signals, ECRs and VPR of track occupancy, axle counters, is already available in the signal. So this place, there is no doubt we will go for installation of RIU in AutoHut. The difference between these two things, the centralization and this one, is here there was no OFC available, so we had to do all the trenching, we had to do the hard work. But in MSDAC sections, we don't need to do the hard work because OFC is already available. That's the only difference between these two. So these are the kinds of schemes that we are implementing in auto section. Yes, we had another problem that whenever in Medchal to Bolaram section, we had offset problems. What when we are saying offset, what we mean is we had an absolute location survey. Absolute location survey is nothing but physically going and measuring the distance between signal, center line of the station, signal, all these things. We go physically measure the distance. So now whatever my absolute location is there, it is based upon one reference line. I measure all the absolute locations. But translate this to what the loco pilot actually needs. The loco pilot, he receives a caution order, and that caution order is with reference to kilometer stones or traction mass. Now let us talk about kilometer stones. Kilometer stones, these are supposed to be at 1 kilometer. Every 100 meters they are supposed to be there. But what had actually happened is these stones that are supposed to be 100 meters apart were not 100 meters apart. They were placed at non-uniform distances. So now when we are going to when we actually found out how much error is there, this is the error that we found. We had a distance of error distance of 150 meters to 170 meters at certain locations. So how did we go about solving these problems? What we did is we measured all the interdistances between the kilometer stones also. And whenever we have a caution order, say at kilometer number 100, at kilometer 100 bar 1, we need to impose certain speed restriction. What we did is we mapped this 100 bar 1 with the absolute location that we physically measured. And that we mapped in the application data, the logic code of station TCAS, and we mitigated the discrepancies. That is what we did. This is the offset problem that we faced, and this is how we solved. So that's it. Thank you. This is how we implemented TCAS in auto section.
Kashyap, can you just repeat the last part of your presentation regarding these offsets for better understanding?
Okay, sir.
Please repeat that last, no, the last portion which is mentioned regarding kilometers, 100
Sir,
meters.
when we are actually say we are at one station, say Medchal. Say it's Medchal. Next station is Gundlapochampalli, and next is Bola. Now, when we are running the train from Medchal to Gundlapochampalli, what the driver views, his loco pilot views, is his caution order, that is with reference to kilometer stone.
It is with reference to kilometer stone or with reference to OHE mast?
It is with OHE mass, sir. It is with OHE mass, but I am saying kilometer stone because that is easier to understand.
Okay.
Sir, it is all these kilometer stones are supposed to be placed at uniform distances of 100 meters.
Agreed. Agreed. It will be all haphazard. In fact, stones also may not be available. Which is the guarantee that stone will be there?
Yes. Yes, sir. Yes, sir. Now TCAS when it is running, it knows the kilometer number or the absolute location number of our reference station. Say that is Medchal station is my reference, and I run TCAS runs the train with the physical distance measured from the center line of Medchal station. Now the caution order, the speed restriction that has to be given to fed to station the TCAS, that will be kilometer number. Because there is haphazard placement of kilometer stones, the absolute location of TCAS measured with physical distances will not match with the kilometer number. Now how? Because now say I need to restrict the train speed at a particular kilometer number, say 100/1. If we blindly go with the kilometer stone number and impose a speed restriction there, we cannot impose the speed restriction at the place where it is actually intended to. Because TCAS reference will be its physical distance and
I
caution
agree
order
with
is with
you.
reference to kilometer.
Kashyap,
So we
Kashyap,
do a mapping, sir.
Kashyap, I think we
Sir,
should take a submission to Railway Board that
sir.
henceforth in RE area the reference should be only OHE mast because that is a firm structure.
Yes, sir.
And your mapping should be with respect to OHE mast because that is a firm structure,
Yes, sir.
isn't it? Kilometer stones is already rubbish.
Yes, sir.
Let
Yes,
like
sir.
OHE take the reference of kilometer stone and number their masts.
Yes, sir.
But we for TCAS application should take we should map the OHE masts instead, and
Yes,
that
sir.
should be overriding, and that's what should be given in the caution order. That's my submission. That's all.
Yes, sir. It is we from Medchal section it is electrified and we have references of OHE mass itself. We have taken that reference only. But beyond Medchal, from Medchal to Mukhed, we don't have electrification. So
True, but
there it is only
true.
kilometer zones that we have as reference.
Okay. But by 23, 24, we will be fully
Yes, sir.
electrified, and I'm sure the maximum TCAS installations will come up in 23, 24 only, not before that.
Yes, sir. Yes, sir.
Functional.
Wherever
And remote
OHE masks
functional.
are there, we are taking OHE mask only.
Okay, thank you.
Okay, sir. Thank you, sir.
Kashyap, you have told about absolute distance. Are you taking curve also in account while doing survey?
Yes, sir. We are taking distances along the track, sir. not the distance from point to point, but distance along the track.
Okay.
So that will take care of the curves also.
Kashyap, one
See,
more
that
thing.
is okay. But if curve is there, and let us suppose if 8 kilometer section you have measured, but it is having curve. So absolute distance is coming about 7 kilometer, and during planning, we have taken 3 towers within that 8 kilometer. So, but absolute distance is only 6 kilometer. Then how you are taking care of that?
Sir, radio planning is done with reference to the absolute distance. However, this kilometers location mapping is done with reference to the track kilometer, track length. So we need to take care of both, sir, and we are doing both. For radio planning, we are using the actual physical distance, and for location mapping, we are doing survey of track lengths.
Shiv, what can be the maximum distance of tower from station TCAS?
Sir, there is no such restriction right now, and we have not faced a major issue in distancing of the tower, sir, because the limiting factor of placing tower very far would be losses, RF losses. So this we have solved by using optic fiber from station TCAS to tower. So optic fiber will also take care of the losses, and we don't really have a major restriction on how far the tower can be placed. The only restriction would be how well we can feed power supply to the radios that we use. That is the only restriction, sir.
Station TCAS is connected through OFC as well as what you're taking what for power cable actually?
Sir, power cable, it is for powering on the radio modems. Radio modems use 24-volt power supply, sir. So we use DC-DC converters to feed 24 power supply to radio modems. And another power supply would be for aviation lamp that is placed on the top of the tower. So when we are going to place the tower far apart, we are going to depend upon the power cable only. So far a longer power cable is much less reliable than a shorter power cable. So that is the only restriction, sir. There is no other restriction.
Yeah, regarding one doubt or query, that is there any criteria we are following for provision of this RIU bar STCAS with the tower in the midsections? Because few places I have seen they have placed RIU, few places in the midsection they have provided STCAS with the tower. So is there any criteria then how it is being placed?
The criteria is RF coverage. So one station TCAS tower, if it is unable to cover that particular area where we need to install TCAS, there we are going for station TCAS with another tower. And when already RF coverage is available and we only need signaling inputs, there we use RIU. This is the criteria.
That means there cannot be any RIU without the station or LC TCAS.
Yes, sir. RIU is a slave unit of station TCAS or LC TCAS.
So RIU
Station
will
TCAS
never
can-
communicate. RIU will never communicate with tower.
Yes, sir. RIU is a slave unit. It is like an
Yes.
object controller of EI.
Yeah, it has nothing to do with the RF coverage of the tower.
Yes, sir. It has got nothing. It is not connected to tower. RIU is not connected to tower. It is connected to station TCAS. And
Station
station
TCAS.
TCAS is connected to tower.
Correct, correct.
So if RF
Amra-
coverage is available, we go for RIU. If it is not available, we install a new tower and connect it to another station TCAS.
No, midsections we can install STCAS and tower and but obviously this coverage of RF will not have issue, no? Because why I am telling, some places we are having we have provided this RIU in IBs and midsection LC gates due to cable cut or in the whatever I feel the non-standard modems are being used. I think these modems are getting hang, and this is resulting into lot of failures.
The modems are the modem modules are also for RDSO approved make, and cable cut, for taking care of cable cut, we are installing RIUs. We are connecting RIUs through a ring path.
Kashyap,
That is
what
the
he's telling,
sir.
what Mr. Kumaran is telling is valid. I think everything, sensitive equipments, everything what we get is as per RDSO specifications and as per with RDSO inspection. Still things
Sir.
fail. Still things fail.
Yes, sir.
That's
Yes,
what
sir.
he's trying to drive home. It may be RDSO approved, RDSO inspected, but this is a weak item, weak link, which is failing
Yes.
frequently.
Yes, sir.
Sir,
That is
this is
the
Farooq.
reason we know that more electronics means more hanging. That is why we try to in our implementation for auto section, instead of having RIUs at each and every signal, we try to centralize all these signaling inputs at a particular location wherever GUMT is available, and we minimize the number of RIUs and we place them at centralized locations. That is what we try to do, sir, because we are also aware of the problem, and finally all of us are from open lines.
You are right. That should be the only approach. We have to minimize.
Actually, Kashyap, why Kumaran asked that doubt is because there are a lot of undesirable breakings on account of modem hanging, since it has been connected on 6 quad. And as far as the coverage, first of all, this is CSE. Am I audible?
Yes, sir. You are audible, sir. However, your voice is very low, sir.
Acha. Is it okay now?
Yes, sir. It is okay, sir.
It's okay, Bagundi, Bagundi.
What happened, like if you take an example of LC3 and 4, now these LC3 and 4 are connected to the station at a distance of 3.5 to 4 kilometers. Okay.
Yes, sir.
Now this 3.5 to 4 kilometer, we could have gone for a tower also or not? Though we haven't gone for it, but I'm asking, since his doubt was the same doubt that despite of having a distance of 3.5 kilometer from the station, we have gone for RIU. Could we have gone for stationary TCAS with tower?
Sir, the RF coverage will ultimately, it will depend upon the terrain. When there are hilly features, the coverage will be very much less. When it is a plain area, the coverage will be more. But as a general rule of thumb, we are considering the coverage of a tower, 40-meter height tower, as 4.5 kilometers from the tower. As 4.5 kilometers from the tower. So when we are already having when this gate is placed at 3 kilometers away from the station, so that means it is already having RF coverage. When it is already having RF coverage, installing a tower is a costly affair. So they might have avoided the tower and installed RIUs. But RIUs, sir, connecting it on quad cable is wrong. We should connect it only on OFC, and specification has also been corrected that way, sir. Initially,
Now
that was a developmental project and it was connected on quad cable.
it has been
Now we
revised
are
now.
going only for OFC.
Kumaran, but what about your LC9? That is almost 7 kilometers, no? There's one more LC which is connected on quad. That is LC9. It is connected to, I think, SSPD, I think. So that's also, and that is almost 7 kilometer away from the station, and it is connected on RIU. Anyway, that has been done in the. Acha, then one more doubt. In fact, what I have discussed or heard from OEMs that while deciding the movement authority, we take 3 signals into consideration. Am I right? Or because you told we take 2 signals, entry and exit only. And when I have discussed this matter with earlier, with the OEM fellows, they were telling we will take 3 signals into account.
Sir, we have taken 3 signals, sir. I was telling 2 kilometers. 2 kilometers mean 3 signals, sir.
3 signals, no? That's what.
Three
You
signals,
started
sir.
with
Three
the
signals.
entry exit concept, then you're talking about the second signal only. But let us be very clear that while deciding the movement authority, 3 signals will be taken into consideration. Hai na?
Sir, I was talking about when I was talking about 2 kilometers, I was talking about the communication overlap. Here, sir, for deciding the movement authority, it is the entry signal aspect and exit signal aspect would decide the movement authority of that particular section. However, movement authority calculation is done in an iterative way, sir. If the second signal fails, second signal is not going to give movement authority, we will not extend the movement authority beyond the second signal. Even though entry and exit aspects of the signal dictate other way, they dictate the aspects are in such a way that movement authority will go beyond the second signal just on the based on these 2 signals. But say on the third signal, it is saying that so and so condition is not favorable for extending movement authority beyond second signal. So we curtail the movement authority only up to second signal. So that is calculated in an iterative fashion.
Now, in a simple words, we can say if your home signal, the train is before home signal, then the movement authority, if your starter is in proceed aspect, will be given up to LSS.
Yes, sir. But say there arises a case where starter is in proceed and LSS is danger. Such a case would never arise with our interlocking. But let us say such a case has arisen.
Yeah.
When such a case is arose, movement authority will be only up to starter.
Right. Okay, that's what I wanted to clarify.
Okay.
Kashyap, what will be your planning for 2 stations? Because one station is A, one station is B, and the distance between 2 stations is 11 kilometer, and we are planning with 3 auto gomtis. So, what will be your planning regarding TCAS?
Sir, our planning would with 3 auto gumtis is first we'll do the desktop RSSI survey. We'll see whether with due considerations to with all these curves and all these things, what is the radio coverage? If we can achieve the radio coverage throughout, including this communication overlap for handing over, smooth handover, including that, if we can cover with just 240-meter towers, we'll do it only with 40-meter towers, 240-meter towers at station A and B, and then install RIUs at each gumtis. But if at all the RF coverage is not sufficient, we'll need to introduce another tower in midsection. Definitely that midsection where we are going to introduce that tower would be near the gumti for reasons like power supply. Reliable power supply will generally be at gumtis only. So we'll go for a tower in one of the midsection gumti, and we'll need to redesign everything for TCAS, considering that extra tower also to be a station TCAS.
Uh, Kashyap, earlier you told that if the block section length is more than 7 kilometers, it will not be possible to achieve 2 kilometers of overlap. Therefore, there necessarily has to be one more tower in between, one or more.
Yes, sir. Yes, sir. 7 kilometers is not an absolute figure, sir. 7 kilometers is it is coming out of the rule of thumb where we say 4.5 kilometers is the tower coverage, 40-meter tower coverage. But is
Correct.
that is not an absolute figure. We'll need to confirm it with the survey, RSSI desktop RSSI survey.
Absolutely, I agree with you. That is only a thumb rule, something for planning purpose, estimation purpose only we have to take.
Yes, sir.
Kashyap, what precaution we should take while shifting the relay room to 50-meter away from the existing room?
Sir, sir, for these things, TCAS, when relay room has shifted, TCAS cannot be commissioned before the interlocking has been commissioned. So what we can do is, before commissioning the interlocking, the maximum thing that we can do is placement of station TCAS and wiring of all the repeater relays that are required for TCAS. This is the maximum thing that we can do. And then cabling to the new tower from the new station, new relay room to station. This can be done parallelly. But commissioning TCAS has to be done only after commissioning of interlocking. That can be brought into use only after signals have been put to use. Precautions, sir, because the precaution that we need to take is, we don't want unnecessary signals that have not been commissioned to pass on to TCAS enabled locos. I would suggest, sir, we put the TCAS, we switch off the TCAS before commissioning interlocking. The existing relay rooms interlocking also, existing room TCAS.
How much gap do you anticipate between commissioning of interlocking and commissioning of TCAS?
Sir, 1 or 2 hours only, sir. The
Achha,
gap
2 hours
is only for wiring.
Okay.
Wiring and putting TCAS in place.
Okay.
If the yard layout doesn't change, yard layout changes, then we'll need time for fixing RFIDs and all these things also.
But all that can be fixed in advance, no?
Yes, sir. That can be fixed in advance, provided that can be done, sir. It depends on site conditions. Say we have
Of course.
certain points that are being introduced, say in tripling or doubling kind of situations. There our RFID tags will break. So we'll need to do that only after these things have been put in place.
Agreed. So, as you said, if there is a minimum alteration, yard alteration, it is only about an hour. But more the complication in the yard, etc., then it may range up to say 8 hours, 10 hours, 12 hours maximum.
Yes, sir.
Isn't it?
Yes, sir.
One question from me.
Sir.
One question, Kashyap. You have commissioned TCAS in Bolaram Mirchal.
Yes, sir.
Using the existing auto signaling arrangements commissioned by RVNL.
Yes, sir.
Right, and because I was part of that planning, so I only want your experience. Please share. Did you find anything that we could have done to facilitate commissioning of TCAS in a more simpler way? Because other people also will be doing automatic signaling, so they have to ensure now that they do it in such a way that everything, including the room size, the power supply, the fiber cabling, and even the space for tower near the building should be available, so that TCAS commissioning is thereafter facilitated. Can you share such things, some lapses, something which we could have done better, or at least others should do?
Sir, in this MSDAC section, we were comfortable with the installation because we already had the fibers available.
Anna, I don't want you to praise me or anything. I want you to share your difficulties. Anything that we missed, we could have done.
Sir, we are planning to commission same scheme auto section in Falaknuma to Umdanagar section, sir. There our idea is to commission with EI TCAS interface, because this one is also from MEDA, and MEDA EI has been already tested in RDSO lab. EI TCAS interface, it has been tested in RDSO lab with MEDA EI. The problem that we found is, whenever these auto signals are available in EI only for one direction. Up direction, say it is available in another one station. Down signals, all the auto signals of downside, they are available with the other station. But TCAS operates through radio, and radio is only through physical proximity. So it doesn't care about direction. It only needs physical proximity to that particular tower. So we need indications of ECRs of both the stations, both the directions, up and down. This had this been done already, sir, it would have been much simpler for, it would have facilitated EI TCAS interface in Falaknama to Umdanagar section.
Okay. So what you have done to overcome this, you have provided additional OCs?
Sir, we are going to wire these signals ECRs that are available in same Gumti to the spare IO bits already available. Spare IO bits are already available, so
Okay.
we are able to do it. Otherwise, we should have gone for more IO cards in OCs.
Mhm. Okay, here you had the spare available.
Yes, sir.
Anything regarding the size of the room? Could that be? Should it have been little more?
Sir, regarding the size of the rooms, distributed
Gumti and
EIs, distributed EI of Falaknuma station, that end cabins are very small, sir.
clumsy,
They
isn't
could
it?
have been larger in size, sir, for OCs. Then
Yes.
we found space constraint.
Okay.
Space constraint is there.
Okay. So this is what I want you to also list out in one slide
Sir.
when you upload your presentation as a guidance to all the SNT fraternity who are going to commission automotive signaling,
Yes, sir.
so that they take care of these points.
Yes, sir.
Thank you.
Kashyap, why additional bits are required in IO if you're interfacing TCAS with EI? Because already you are proving indications of point as well as RECR and all, which is already available in EI. So then why you're requiring extra bits for that?
Sir, for what happened is in this auto section, MEDA EI is controlling auto signal through OC of only one direction. Up direction has been all the auto signals are controlled by one EI, and other direction are controlled by another station EI. So up and down signals, when we are when this station, one particular station is covering up signals, down signal indications are not available with that EI. But TCAS is based on RF, which is it only needs physical proximity. So it needs indications of both up and down signals. Those other signals of the other direction that are not wired to EI already, these needed to be wired. So
Okay,
that
okay,
is
okay.
why we are needing more IOs.
Kashyap, there are a few questions in chat box also. Anwar Basha is asking RFID tag can be replaced by maintenance staff. Is asking.
RFID tag, sir, RFID.
Can RFID tag be replaced by ESNs?
Yes, RFID tags can be replaced by technicians, maintenance staff. It needs to be programmed, and we are having handy tools. We are having RFID programmer kits that are portable, so they can be easily programmed. Whatever RFID tags that we have placed, these will already be pre-programmed in that programmer in a database. So we just need to select what tag that we need to program, and we need to physically place over the RFID tag, and the RFID tags get programmed. This can be fixed, and the fixing arrangement is also very simple. It is just nut and bolt arrangement. There is a clamp to the RFID. The clamps, they go beneath the sleeper. They need to be placed over the sleeper. Clamp will go beneath the sleeper, and bolts need to be tightened. So that is very simple. Fixing of RFID tags, programming it is easy.
Kashyap, Srinadevji Guntakal here.
Sir,
Actually, yes, as I have explained in auto section, the aspects of down signals are not auto signals are not available in one of the EI. But I think for TCAS, it needs only aspects of the signals, no?
yes, sir.
So why we go to interfere the EI existing EI? We can just simply the transfer the aspects through RAU. That will be sufficient, I think.
Sir, the thing is, we have MEDA EI, and MEDA it had been willing to share its EI protocol with TCAS OEMs, so that it can
Okay.
be directly interfaced with TCAS.
Okay. Means
So
RIUs are
then
not required.
normally, if we are going to wire through RIU and station TCAS, we
Yes.
need to take the ECR and TPR, everything these need repeater relays. Repeater relays need to be picked up, and these repeater relays are physically wired to station TCAS.
Shiva, whenever when protocol is shared, na, it reduces
Yes,
a huge lot of hardware requirement.
yes,
Yes,
sir.
yes, yes.
Yes, sir.
In any application, you can see once the protocol is shared, your
Yes, sir.
hardware requirement is almost becomes negligible. Only a cord, I think. It boils down to only a cord.
Yes, sir.
Serial port exchange, sir.
Exactly.
Okay.
Kashyap,
Means for other
second
OEMs,
question is
it's
from KB Satnarayana.
Sir.
If due to any reason signaling cable caught damage by while approaching a home signal, what action will be taken by TCAS?
The signaling cable, when it has been damaged, definitely the signal ECR will not get picked up. Whenever we are wiring any ECR for TCAS, we are doing it from the relay room. So if home signal cable has been damaged, ECR of relay room, original ECR that we are using for signaling interlocking itself will not get picked up. And then that will be definitely it will be considered as RG. And TCAS will also detect red aspect, danger aspect, and it will try to apply brakes. Interlocking itself has responded to the cable cut or cable damage in such a fashion so as to not pass the train. TCAS will also respond in the same way.
Kashyap, is this
Sir,
Kashyap, DST project
sir,
Secunderabad.
sir.
Kashyap, in one station, when we are converting PI to A station, their station TCAS needs to be changed to interface with EI, or same station TCAS can be used for EI interfacing.
One station TCAS, it will cost 40 lakhs. It has costed us 40 lakhs. So the decision is up to us. Before commissioning station TCAS, we cannot, the interlocking, we cannot go commission station TCAS. And how far we are willing to have downtime of TCAS, how far we are ready to have the downtime will definitely, that will determine whether we need to buy a new station TCAS or use the released one.
No. That whatever now we are using for PI, but that means relay interfacing. The same can be used for EI interface also, or that is different from this. That can be used or
It
not.
is same. The equipment can be definitely used, but whether we use it or not, whether we buy a new station TCAS or not is determined. It will be determined on cost considerations and how far we are able to willing to have a downtime of TCAS. That's all. But
Okay.
the same equipment can be used.
In tenders, whatever you are floating, there is any provision that any additional loop lines are coming that can be accommodated in the same whatever tender you have worked. For example, you are doing in Alampur Road and these Nagorsol stations. So in your tenders, there is a provision of minor alterations are there or not? That can be accommodated, or we have to prepare separate schedule and that can be used. That has to be used.
In our tender for 1200 kilometers, we are having minor alterations. We can carry out to 50 minor alterations. But a new relay room with two additional loop lines at Alampur, definitely it's not going to be a minor alteration. It's going to be a major one. Nagarsol also, it is going to be a major one. In new relay room, is a major alteration.
Okay. Thank you, sir.
Yeah, one small doubt. Actually, so in Thalapur station, that EI was MEDA and the TCAS was the HBL. But but EI stations also, they are separately wiring the relays and proving to the TCAS. Why so? They cannot use the EI functions to the TCAS directly that without wiring this external relays? Because
That-
now the external relays are causing contact failures, and which is resulting to the EBs in so many cases. At least the EA stations, why they could not utilize?
in EI stations when Tellapur was done, I think Tellapur was done in around 2016 or 2017, right?
Yes, yes.
So when that was done, EI to TCAS interface is still in testing phase. It has been implemented in RDSO lab, tested and implemented in RDSO lab,
Okay.
not on the ground, not the field level. Field level, the testing is going to start from Monday by RDSO.
No, but even if you see your specification, that is a 3.2, it is already there because the electronic interlocking stations, but we can take from this, but I don't know how it was. ठीक है वो.
3.2 itself, it is having interface that is our vision,
हाँ.
but it has not yet been implemented.
Okay.
Sure. Taking HR is more safer than taking ECRs. So if we are means if inputs are taken directly from EI means with protocol converter. So are you going to get the things done from ECRs or through HRs? Is any planning like that?
Sir, ECRs only, because ECR is the final relay that proves the lighting of the lamp also, lighting of LED signal also. Instead of just the control relay, it will prove the lighting of signal. That is why ECR is being used. So even if we directly interface with EI also, we'll use only ECR.
Only by advantage is that external relay wiring can be avoided and contact failures will not be there if you take directly from EA those functions.
There are other questions also. One is from Sandeep Wagmare. Whatever signal aspect is wired in STTCAS. So whenever any aspect fails, whether it is going to most restrictive aspect by itself.
Sandeep, please repeat your question. I couldn't get it.
It will not work.
It is from
That
Sandeep
was not,
Wagmare.
sir. Actually, that was not the question. Actually, initially some question has come. For that, I have given the answer, sir.
Regarding this RF signal failure, what we are
No, sir.
seeing.
Home signal cable if cuts.
Yeah, let's go ahead. After all, I will ask.
Sir, that actually if any cable cut happens, what happens to because someone asked, na sir.
Yes,
For
Sandeep.
that, I have given the answer, sir. It will go to most restrictive aspects.
Okay, Sandeep, okay. KB Satyanarayana has asked what is the life of RFID and what is the maintenance schedule, maintenance activity actually for RFID?
Maintenance activity, there is a schedule that has already been prepared by RDSO. And regarding codal life of all station TCAS items, that is still being deliberated upon by RDSO. I can share the maintenance schedule of all station TCAS items and loco TCAS items. I can share it little well later. It has already been given by RDSO.
Is there any scheme for track identification numbers? Yes.
Track identification number.
Yes, yes.
Rishabh?
Is
One
audible?
question.
Am I audible?
Yeah, now
Audible here,
audible.
Chituri.
That track identification number you have shown, na, that RFID layout.
Yes.
Is there any scheme for that, or how, on what basis we will decide this is the track identification number?
RDSO in its specification, it has given guidelines for tin preparation of RFID tag tin layout. Based upon that, we do it. But the basic idea is simple. We divide the station and block section. Entire block section is one. It has one tin.
Okay.
Point zone has another tin. Berthing tracks have another tin. That is the basic concept.
Yeah, that is tin is based on the train movement. We can call it as a route section plan. If you are having sand dump, then we will have the two different tin. One tin for towards sand dump and one tin for towards the reverse movement. It is just like a replicate of our route section plan.
Okay.
That tin number allocation. Here I got one doubt regarding this RF signal, because we are facing a lot of signal failures, RF signal. So the towers are 30-meter height and two antennas are available, which is fixed in the tower. And still the communication mandate zone. What is the reason for RF signal loss or failure? Because we are having two antennas.
The RF loss may be due to many factors. One is due to, say, the antenna has physically turned due to high wind. That is improper fixture of the antenna. One. Another reason may be whether proper design has been really taken. Generally, the margin for weather problems will be 30 dB. Whether that has been considered or not, this needs to be taken care. Physically, whether the cable is intact or not, whether all the connectors are tightened or some connectors are loose. Another very basic thing is no underground coaxial cable has to be laid. No underground coaxial cable will definitely lead to RF loss.
No, here in the section, these radio modems are placed in the tower itself. So there's whatever the LMR 400 or LMR 200 cables are there between the antenna to that radio modem, but that is not buried. But the problem is in the communication mandated zone also we are having a lot of RF signal failures in the Telapur, Gollaguda, into the Sankarapalli and all. But though two antennas are installed, and this actually this OFC cable is laid between this TCAS to the tower, and whatever the coaxial cable between the radio modem to the radio tower is there in the tower itself, but still the radio signals are failing. Then purpose of two antennas, I think it is not serving. Then is there any solution, and the future installation, how to overcome these problems?
When we say that RF coverage, there is a problem, it means the problem has been with both the antennas. So whether we are able to detect with the problem when the problem is there with just one antenna, that might be going. It might have been gone unnoticed.
Kashyap, we may ask OEMs to share their opinion on this. What is their opinion? What their experience, their analysis?
Sir, I think Gullaguda is for HBL.
Let them. They are on the forum now. Let them share their opinion. What do they think?
And this one more stage problem also we observed. This whatever signal failures are there in the underneath of the tower areas.
Muralidhar available? Muralidhar from
Yes, sir.
education.
Yes, sir. Yes, sir.
Please go on.
Yeah, we have, as Kumaran DST sir pointed out, the RF communication issues. We observed in the IBs only, sir. Recently, last 3-4 months, we observed in IBs only, and particularly because of the data flow communication used from STCAS or IBTCAS to the radios. So it is quad cable we used, RS-232 cable we used, copper wire cable we used, and during a long run initially we didn't had any problems, sir, initially, and last 5 years we didn't had, and last 3 months only we observed some RF communication issues, and when we studied by providing a sniffer radios, we identified that data is not reliable, data is not moving from going from station TCAS to the tower radios. Then we changed the copper wires to OFC cables. So the data communication is improved, and the packet loss is reduced, and the RF communication has improved, sir, in the IBs, particularly in the IBs. Yes, sir.
Improved, but still failures are not come down. Even after replacing the OFC from 612.
That is regarding the MAC code issue is not being communicated with the other locoticas, other firm locoticas, OEM locoticas, or except only 1 or 2 cases we noticed. Means 95%, 98% is reduced. Only 1 or 2 cases we noticed that there is a packet MAC code issue or some SSP non-registration. It is observed. Static speed profile is not updated. So other than that, there is no issue, sir.
And we have observed at Lingampalli, whenever the train is going in the loop line, that is bottom of the tower side, there also the mode changes are taking place and the radio signal strength is less. What is the reason how this problem is?
Sir, it is not the radio signal sensor. It is only the, sir, in the loop lines we are not regularly moving the trains. TCAS trains are not moving regularly in the main loop lines. They are moving only in the main lines. So the relay contact inputs to the TCAS, it is not getting updated regularly. So when any contract operation, any contract is missing in between, then we are observing a mode change or the this thing.
Different issue. That is again, I will come next for the relay contact. Why your port is getting hang? But I'm telling about the RF signal strength in the bottom. That is a tower lower side. Whenever the trains are going in the loop lines, that RF signal strength is very less and is causing the mode change.
In the loop lines, we need to check, sir. Once we will check up and then we'll update you, sir. In the main lines, there is no issue observed. In the loop lines, we'll check up, sir. As you suggested, we'll check and then we'll update.
Yeah, still this mode change cases due to communication break. Even in the January month also, we are having around 27 mode change failures due to communication break. So actually, what is the reliability of this RF communication? This is to be looked out.
Okay, sir. We'll check up, sir. The data from the Google Sheet, we'll check and we'll reply to you. Hello.
Yeah. Okay. Note.
Yeah.
And this one more issue we have observed. This also the majority of failures are contributing. If you see our relay circuit, relays are operating and there is no issue for the signal system. It can clear off. But whereas the relay contacts which is proved to your STCAS, those contacts are not becoming that inoperative, which is causing the out of correspondence signals, and sometimes these points are not getting operated and causing these EBs. Why this is happening for your TCAS? Because same relay contacts are used for signal circuits, there is no issue. The relay contact which is used for TCAS is finding the non-operative. What is the reason?
Sir, initially we didn't get any the input from the TCAS relay contract input to the TCAS. So now we during maintenance we started checking all the contracts. We are meticulously we are checking all the contracts is operating or not and on monthly basis. And now the issue is reduced, sir.
No, see,
We are
the
checking the early.
no. What is my question is that why the contact through to the TCAS inputs are getting but
Sir,
non-operative? Is there
it is
any
physical.
your card port is hanging, or is there any card issue, or what is the exactly? Because
Sir, in Shankarpalli, we changed one relay. Because of the relay, the contact issue is observed. We changed the relay, then the contact is resumed. Now we started checking meticulously all the contacts. Any issue is there, we will highlight to you for the issue. Then we'll take your help to restore it back for this thing, normalizing the input.
So that means that means as per OEM, the issue which Kumran has raised is at present the problems are on the relay side only. Nothing identified towards the HBL equipment.
Sir, yes, sir. Because we identified 1 2 cases in Shankarpalli itself, sir. Shankarpalli itself, we identified the contact is not coming point contact. That is particularly we are not getting the input. So at one case we changed the relay. So by changing the relay,
Sir,
What
this
about
is
the
what,
other?
sir, this is what Stenji is telling, sir. These cases we found in Bidar. These cases we have seen at Jairabad. This case we have seen at Lingampalli. Only, sir, that relays which it proved to the STCAS is becoming non-operative, whereas the same relays which is proved to our circuit is functioning well. But why?
So other since the problem is common to all the three, others can also respond on it. Meda and the other, what is the other firm? I don't know.
Connect, sir.
Connect. They can also respond on this.
Ashish,
In
Tarun,
Veda stations,
Jitin.
we have not faced such issues, sir. In Veda stations, we have not faced such issues. Issues due to real contacts.
Kernex can throw because as Jairabad we got this issue, Bedar we got this.
Sir, in Jairabad, actually, the gate 32, the double yellow issue, sir. The double yellow issue is mainly due to because of from railway railway contact itself. One of the yellow we didn't receive, sir. That even we saw it in digital log also of railway also, sir.
Sir, this is again the one more case is telling, sir, what we have found that signal which is showing the attention aspect, that is a bottom yellow and the top yellow supposed to show, but the bottom yellow is fused and the top yellow is lighting. But whereas in TCAS DMA, it is showing the undefined. That means the DMA is showing red. So this bottom yellow fusing cases can come, but why to show red? Because they are also unnecessarily the EB is getting come, or maybe out of correspondence signals are coming. This Kashyap can throw light on this design issue.
Sir, actually for double yellow, both HECR and HSCR inputs we need to get from TCAS point of view, sir. So if one of the if double yellow HHECR input is not received, then station TCAS will send HECR input as most to that logo, sir. So if mainly HECR input is not received and only HHECR input is receiving, then station TCAS will send most aspect as red, sir.
No, if you see that permissive signal, even this attention aspect, even the bottom yellow fused and top yellow slitting, still my driver will pass the signal. But whereas in TCAS, it is not being allowed. Why?
As per railway board has very clearly defined that only top yellow lighting and bottom yellow fused is the most we will consider that is the most restrictive aspect. If it is an invalid signal, invalid aspect as per NSR. That is railway board's policy, and we can deliberate upon it, but decision is up to railway board. That is my opinion.
Yeah, because if you see from the signal side, even now the loco pilot comes, and if you see the bottom yellow fuse, still the top yellow works, and permissive signal still he passes. But if that the TCAS fitter loco is there, then it stops.
Sir,
In fact, we were told to alter our signaling circuits also, that bottom yellow is not lit. We need to keep it blank instead of showing only a single top yellow being lit. In fact, we were told to do this alteration.
No, that is different, because whenever the top yellow is fuses, then automatic switching over of the top yellow. And that we have done it alteration. But in this case, the signal is showing the attention aspect, but the bottom yellow is fused. But this is not that auto switching.
Bottom yellow, top yellow fuses, it is automatically HG instead of HH. But bottom yellow fuses and top yellow litting, the case should not arise. For permissive signals or any other signal, the case should not arise that only top yellow is litting physically. Physically, both are litting. One ECR has not picked up. HECR, bottom yellow ECR has not lit up. Again, the case should not be arising. We were told to do that circuit alteration.
Any other questions from any other participants? Sir, can we finish the presentation, sir?
Yes, please. Yes, please, IP.
Thank you, Kashyap. It was very interactive and very informative. Lot of information we got, and a lot of doubt also you cleared. And it was too interactive. And thanks to OEM representative also. And sir, next week our training will be hosted by Deputy CST Project Headquarters, sir. So, sir, we are ending, sir.
By concluding words to those who are watching part of this webinar, please commission your automatic signaling TCAS compliant. Take all precautions, whatever is required in terms of building size, power, fibers, tower space, when you commission the automatic signaling. Please make it compliant, because you have to take care of it in the field. That's my humble request to all the people who are involved in commissioning of automatic signaling now or will be doing so in future. That's all. Thank you.
Definitely, sir, we will take care of that, sir.
Sir, because sir, you asked about what has to be done for commissioning TCAS when new relay room has been commissioned. Sir, we also have to do SAT, site acceptance test. Site acceptance test for TCAS is nothing but loco trials. So this also has to be looked at, sir. For carrying out SAT, we need loco movements.
Okay, sure.
Okay, sir.
Okay, sir, then we'll finish, sir.
Please, good day to everybody.
Okay, thank you, sir. Thank you, everyone.
Thank you, sir. Thank you.
Thank you, Chef, and thank you, the OEMs present.
Thank you, sir.